All right, we're going to take a look at Finance Part 3, and really this section is all about loans. And we call them, you'll see this word a lot, an amortized loan. And really it's just like those payout annuities that we were working on, but from the bank's position. They loan you money and then you make monthly payments to them, which will reduce the loan's balance. And what happens is the amount of interest is going to be calculated on whatever your current loan balance is. So as your loan balance goes down, the amount of interest that you owe is slowly decreasing as well as you're making those payments. So again, you're going to see like that same exact formula for a payout annuity, but we're thinking about it in terms of P naught being the balance on that you owe, and D is going to be your monthly loan payment. Normally it's monthly. Sometimes you might see it as annually or other things. And then you see the same variables that we've used before. So let's look at an example to see how this will work out. So exercise 1 here, it says that we have Gio and Dana deciding they needed a more dependable car, and they buy one. The purchase price of that car is $13,518.77. They're going to make a little bit of a down payment, and then they're going to finance the rest in a conventional loan. That's another way to say amortized loan for 4 years at 12% interest. So the actual amount of our loan, we have to take off the down payment. So we're going to take $13,518.77 and subtract off that $1,000. So the loan amount is really going to be for $12,518.77. So using that formula, we're going to write, that's the balance, and we want to figure out the monthly payment. So I'm going to leave that variable D in there. We're going to write 1 minus, and the formula says 1 plus our interest rate, which 12% is 0.12, and we're paying monthly, so we're going to divide by 12. And then the exponent on here is going to be really the number of payments we make. So it'll be negative. We're doing it for 4 years, so it'll be 12 times 4. Again, we could rewrite this as negative 48. That might be easier for our calculation. And then this is divided by that 0.12 over 12. And so the way that I think about it, to solve for this D, it's being multiplied by this whole chunk. So if I divide by that whole chunk, then it would get me what my monthly payments will be. So if I go over, I'm going to use this calculator over here to show you how I would be entering that. And so when we enter the amount of money, it's going to be, let's see if I can make my calculator work here. All right, here we go. So I'm going to write the balance that I'm going to end up paying, $12,518.77, and then I'm going to click the divided by operation, and that creates that fraction for me. Now, in that denominator, I was really going to divide by a whole nother fraction. You can see right here that I circled in blue, and so I'm going to enter that whole entire thing in the denominator. It just makes it a little bit easier. So I'm going to enter the fraction bar button, that A over B on the far right, and I'm going to enter that parentheses 1 minus parentheses 1 plus, I'm going to enter 0.12 and then the division symbol, and it will automatically make it into the fraction that I want to see, 12. I'm going to push the arrow over, so on the far right you see 2 arrows. We're going to click that far right arrow to just get me out of that fraction, close that parenthesis up. I'm going to push the A to the B button, that's my exponent button, and in there I'm going to put a negative 48 because I already calculated that 4 times 12. Now in the denominator of the denominator here, I'm going to put 0.12, division symbol over 12, and that automatically creates those fractions for me. So you can see my payment there, it's $329.67 if you did everything correctly. And so we're going to re-enter that, $329.67. So assuming that there was no interest on this loan, just to kind of do a quick rough double check, one way to do that is to take the amount that I was getting my loan for and just do a quick divide by the number of payments you'd make. And when you enter that into your calculator, you get that it will be about $260.81. And so what should be happening is the actual payment should be just a little higher than that because this will include interest. And so that's my kind of like rough check that I did that correctly. Now next I want to find out the total interest that we pay. So I'm going to take $329.67 times the number of payments I make, which would be 48, because I did this for 4 years and there are 12 months in each year. And it ends up that I'm going to pay a total of $15,824.16. And so if I look at the actual price of my car here, it was actually the loan amount was $12,518.77. So I'm going to take the amount I paid and I'm going to subtract from that the amount that my loan was for, and that's going to tell me how much interest I paid, which if you do subtract that, it'll be $3,305.39. Again, punching that into a calculator. So this is the total interest that I'll pay for borrowing that money. So now, again, we're looking from a little bit different perspective on everything. So we are not earning interest, we're paying interest for that kind of privilege of being able to borrow money as needed. Going on to exercise 2 here, we have Gino deciding to remodel his bathroom. He doesn't have enough cash, it says, so he writes a check on his line of credit with his bank for $12,982. We have an interest rate here, and we have that he wants to pay it off in 7 months. So we want to figure out what his monthly payment will be. So again, the setup's going to be the same that we've been seeing for these payout annuities, and we just saw in the last example, the balance is going to be that $12,982. I want to figure out my monthly payment, which we're calling D. And I'm going to stick my interest rate in there. 8.25% would be 0.0825. Oops. Over 12, because we're doing monthly payments. And this time, I'm only doing this for 7 months. So I could just easily just write a 7 up here without doing much else, just knowing that I'm going to make a total of 7 payments. And again, this is going to be all over that periodic interest rate, 0.0825 over 12. And so it's kind of cool if you're using that Desmos calculator. I'm going to go all the way back over here, is that we have already entered the formula in here. So if I just go and change the numbers a little bit, so let me go and do that. So for the balance here, he was getting $12,982. Our interest rate, okay, I'm just kind of clicking where I need and using the left and right arrows and the delete button to change things around, 0.0825, and we're only doing this for 7 months, so minus 7 there, and I also got to fix the fraction on the bottom, which will be 0.082, oops, too many decimal places in there, 0.0825. And so you can see $1,905 is going to be the amount of my payments for that. And so if I go back to where I came from here, that's what my balance, or not my balance, but my monthly payments are going to be for those 7 months. And it makes sense that it should be close to $2,000 because I borrowed $13,000. So again, doing that kind of like rough check idea, if I took the amount of my payments and just multiplied it by 7, so let's say that it's 2,000 times 7, that's 14,000. It seems pretty close. So it seems like a realistic amount of money there. Okay, for exercise 3, switching gears a little bit here to a home purchase, and we're looking at buying a home that costs $680,000 at 4% for 30 years. So again, we have all the information that we need to plug into our formula. So we're gonna, it doesn't say we make any kind of down payment. So we're gonna say that we're gonna get the loan for $680,000. We wanna calculate our payment. We're gonna have 1 minus, 1 plus, it'll be 0.04. That's what 4% is as a decimal. Monthly payments here. We're doing it for 30 years this time. So we're gonna have a negative 12 times 30, which is the common length of a home loan. And I'm going to put negative 360 because when you multiply that. Again, all over that periodic rate, 0.04 over 12. So again, I'm going to go to my Desmos calculator that's hanging out here, and you can use this for your exam and make it really easier here. And I'm going to enter the loan amount was $680,000. And my interest rate for this house, though, was at 4%. So I'm going to put 0.04 in place of those numbers. again, just using, you just click on which way you want to change and use the left and right arrows as well as the delete button. And my number of payments we'll make is that 360, so it's negative 360. So you can see my monthly payment. Actually, I just realized that's too low, 324, and that's because my loan amount was only 68,000. Let's make that 680,000, and there you go, 10 times as much. So $3,246. I just tilted that. That was weird. Calculator's moving around a bit. So I'm going to go back, $3,246. And 42 cents is going to be the monthly payment. So how much will the couple pay for their home by the time the loan is paid off in full? So we want to take that $3,246.42, multiply that by 360, and we end up that it's 1168711.20, which is over $1 million. Seems crazy when your house is only 600,000. So what that means is you're paying a lot of interest to borrow that money. So if I want to calculate the amount of interest, I'm going to take the amount that I paid minus the cost of the house, and we'll end up getting $488,711.20. So that's how much interest you're paying. It's like almost the cost of the house. Kind of crazy how that works. Now that we know the monthly payments, we can determine the remaining balance at different points during the life of the loan. So we can figure out, for example, like what the balance is after 5 years, which means you'd have 25 more monthly payments to make. So if we can calculate the loan balance after paying those 25 years, you can see like kind of the difference and see what was paid off in 5. So for this, what we're going to say is, okay, we don't know our P0, the balance after those 25 payments, but we know how to calculate it. We're just going to stick that payment amount in 1 minus 1 plus 0.04 over 12 to the negative, okay, it's not 360 this time, it's negative 12 times 25. So really this is going to be negative 300 because we're taking off 60 payments, basically 5 years, and divide by 0.04 over 12. And so our P0, again, going over to our calculator, a nice Desmos. Now I can't use the same equation that I've been using because these were for trying to find the monthly payment. So if I want to find what the loan amount will be, I'm going to have to enter that 3246.42 times, in parentheses, 1 minus another parenthesis 1 plus 0.04. You push the division symbol again, it auto creates that fraction. I'm going to use the arrow over button to the right, so that gets me out of the fraction. And then I'm going to use the A to the B button to get the exponent, which will be negative 300. And then I'm going to push, let's see, the divide. Oops, divide just puts me inside there, so that's not what I want. I want to delete that. I'm going to arrow out to get out of the exponent, and then I'll hit divide. And so that's still not doing exactly what I want because that whole expression needs to be divided. So I'm going to go backwards again and put a parenthesis around the whole entire thing. So I just put a end right parentheses. I'm going to click in front of the payment amount, that 3,246, and put a parenthesis. And so that entire chunk is in a parenthesis, and I put divided by. Then I'll put 0.04, use the division symbol, and then 12. And so you can see that my loan balance is that $615,042. And I'll type that in here. So $615,042 and 33 cents. And so of that $680,000, I'm still going to owe that much. So if I want to calculate how much I have paid off in 5 years, I can just subtract those two numbers. And when I subtract those two numbers, I end up with $64,957.67. So that's how much I've paid off over the course of 5 years. Now I've actually paid a lot of payments, that $3,246.42. I've paid in 5 years, so we'll do 5 times 12, or that's 60 if you'd like. I've paid $194,785.20. And so how much of those payments that I've made in these 5 years have gone to interest? Well, if I subtract those two values, $194,785.20 minus $64,957.67, I end up with $129,827.53. All of that going to interest. It's crazy, right? But that's kind of how it happens. And so we can look at an amortization schedule. Let me go back. And so this link is on the page for this activity page, so you can click on it yourself too and see some kind of interesting things that happen. So if I enter that loan amount that we had, let me do that. So our loan amount was for $680,000. And I put in that loan term. We were talking about doing it for 30 years. So the loan term in years. And again, it does let you enter it in months if you want, or autofills it. And our interest rate that we were talking about was at 4%, which is actually quite low for current rates. And so when I hit calculate in there, you can see that monthly payment matches up, $3,246.42. And if you click on it, it says show amortization schedule right below the comparing the loan rates. I click on that, and you can see what's happening with every single payment that we're making. So with our first payment of that $3,246.42, we have that the principal amount is $979, and then you can see how much interest is being paid. This is actually simple interest on what our current loan amount is for. So if you calculate simple interest, which is equal to that PRT, and we do it on that 680,000 times our interest rate, which was 4%, and times 1 month, so 112, you could punch that in on that calculator and you'll see that that is the interest amount. And so then what's interesting is then if we subtract the amount that we had on our principal from that 680,000, we get that new balance. And so then we will calculate the simple interest again on that new balance. You can see that that would mean the interest would get a little bit smaller, and that bumps up the principal to be a little bit higher. And you continue that pattern, you can see your principal amount is increasing while the amount of interest is actually going down. You're still making the same payments every month, but the amount that's going towards principal versus interest changes as your balance changes. Okay, so we just went back to that page that we were on, and you could see again that your monthly payment never changes, but you are still paying a lot in interest at the very beginning of your loan. And so that thing that we were looking at, that was called the amortization schedule. Most loans will have and show that, so you can see where every payment is going and can see how much you owe at any time on your actual principal amount.